Hey guys, welcome back. This will be Chapter 1, Section 2 notes for Algebra 1. And we're just going to be continuing right off. And you can tell I started through when I started on your book, I went to the core vocabulary. You do not have core vocabulary on your section, but I just wanted to show you these real quick. We will be going over mean. Inverse operation just means undo what we already did. And what it means to take a mean. Mean is another word for what we often use as average, okay? So the mean of the values 7, 4, 8, and 9 is. So it'll make sense more in context. Let's say I play basketball. I score 7 the first game, 4 the next game, 8 the game after that, and 9 in my fourth game. When I look at this, what this means is I'm searching for my average points per game. That's what the mean is, your average points per game. So I would add up how I did in all those games, 28 total points in 4 games. 28 divided by 4 is 7, so I would have 7 points per game. I'm hoping mean this isn't the first time you've seen it, but if it is, then I will review it with you in class further. So now, to solve a multi-step equation, simplify each side of the equation. If necessary, then use inverse operations to isolate the variable. I will be going over all of that, what that means. This part we will not see in the first couple examples in the very beginning, but we're going to focus on this right off the bat. Use inverse operations to isolate the variable. We already talked about inverse operations. That's undo, cancel. But now we're going to have more than one step, okay? So let's just jump into our notes, and I'll explain it as we go through. We will be using the click-through example again. But I have it on my board here because I want to talk about it. So this is the problem we're going to be doing. You have it in your notes. 2.5x minus 13 equals 2. So this is what you should be thinking, okay? This is the variable I want to get by itself. I need to think what happened to this variable, okay? So it was x. Then it was multiplied by 2.5. Then it was subtracted by 13. How am I going to isolate it? Well, before we only had one step to inverse. Now we have 2 steps. But inverse means undo in reverse order. So we are going to work up our operations to get back to x. So you can think, if this was the last thing that happened, this is the first thing I have to undo. So how do I undo subtract 13? I add 13. If I do it to one side, I do it to the other side. That is my properties of equality. So now I just undid subtract 13. Let's see what my result is. These inversed out, canceled out, added to 0, however you want to say it. And that was the whole point of me choosing to undo that first. Now I'm left with 2.5x equals 15. Okay? Now, you can kind of ignore everything you've done up till now. This is like a brand new equation. It's an equivalent equation. Remember, that was one of our vocab words in the last section? This is exactly the same as this as it pertains to the value of x. And that's all I want to know. So now I'm just going to look at solving this one, which is my next step here. If I multiplied by 2.5, well, to undo that, I have to, inverse operation of multiplication is divide each side by 2.5. I've undone multiplied by 2.5. Now I just have to simplify and solve. These will cancel down, and I'm left with 1x, or just x, equals, and you can actually, this is fine to use in your calculator. Hopefully you could be able to do this in your head if you just think of money. 15 divided by 2.5 is 6. And now we could go back and plug it in to check. So you would just take your original problem and substitute 6 in for x. and we know 2.5 times 6 is 15. I don't know if that notification showed up to you, but my battery is running low. I'm going to have to plug in. 2.5 times 6 is 15. Maybe, you know what, since this isn't showing that well, I'm going to skip back to here, and this will probably have the check in it. This was all the same work we did. No changes, okay? Now this is us checking. 2.5 times 6 is 15. 15 minus 13 is 2. 2 equals 2. So this was a true statement. If I plug 6 in there, we did it correctly. All right. Let's do example 2. Now, example 2 is a lot like example 1, except it has a little bit of simplifying in there. So when we have to simplify, you're going to look for distribution and combining like terms, okay? This one, I'm going to follow more on this than on here. I'm going to kind of walk you through it. Explain. Please let me know in class if you like me showing on the whiteboard also. I will make sure I add those in later on. I just think these click-throughs are pretty nice. So we have to solve the equation negative 12 equals 9x minus 6x plus 15, okay? As we do this, we need to search for distribution. There's no parentheses, so I know there's no distribution. Now we have to search for combining like terms. And in case that's new to everyone, it should not be new, but in case we need our review, a like term are two things talking about the same exact thing. So remember we talked about these. I have 9 x's and I have to take away 6 x's. I can actually combine those. They're on the same side. So 9x minus 6x can be simplified. If I said I had $9, but I lost $6, wouldn't you just say, Mr. Whaley, you have $3? Yeah, so that would be the simpler way to say it. That will be your first step here. So first you have to look at combining like terms. 9x minus 6x became the 3x because they're on the same side. If they're on opposite sides of this equal sign, then you have to do inverse operations to remove things. But remember, this is not a remove, this is a combine. This is just someone trying to trick you and not let you know what's on this side. Now that we're to this step, this is exactly like we did in example 1, which is the whole point of these. We are going to make these equations look like equations that we've dealt with. Now when we look at this, take a second and think, here's my variable, what happened first, what happened second? First, I was multiplied by 3, then this whole thing was added by 15. So what should I get rid of first, the 3 or the 15? If you said 15, you were correct. So let's get rid of the 15. How do I get rid of plus 15? Subtract 15. If I subtract 15 from each side, negative 12 minus 15 gives me negative 27. And then the 3x comes down because this went away, which is exactly what I wanted. Now this looks like a problem from section 1.1, a one-step solution. Well, here's my variable. It's being multiplied by 3. How do I undo multiply by 3? Divide by 3. Now if I can divide both sides by 3, negative 27 divided by 3 is negative 9. That equals x. Now remember, how do I check this? Go all the way back up to your original equation. You want to plug this in for x everywhere you see it. So now when I look at it, negative 12 should equal, if I'm right, 9 times negative 9 minus 6 times negative 9 plus 15. And they don't show all their steps here. It should have had negative 81 plus 54. Why am I going crazy? Plus 15. And then when you add all those up, you would get negative 12 equals negative 12, and you are correct. Okay? That takes us all the way through example 2, and you are on your monitoring progress now. So go ahead, start working on that, and come back for the next video. Thank you very much. Sorry, you're going to have a couple seconds extra of staring at my ugly face.